calculations on Hooke's law. Click in the description box below to get the video link for the first calculation for question number 1 and question number 2. We want to look at the remaining part of the questions in this particular video series. So question number 3. Question number 3 reads, if a force of 15 Newton stretches a wire from 20 meters to 20.01 meters, what is the amount of force required to stretch the same material from 20 meters to 20.05 meters? This is a JAMB question. The solution to this question is similar to the solution we solved in the other video, question number 2. You will love to click in the description box below to get the solution to that question. So without wasting much time applying the 5 C's of calculations, we proceed. We write that our first force is given to be 50 Newton, and the force stretches the wire from that to that. So we write that our extension E is given to be L. Okay, let me break it down so that I don't confuse you. Let's correct it line by line. So our original length L0 is given to be 20 meters, and then our L, the extension, the increase in the length is given to be 20.01 meters. So our extension is equal to original length, increase in length minus original length. And this is the same thing as a 20.01 minus 20 meters. If you do that correctly, what you have, that should be 0.01, right? 20.01 minus 20. Yep, I was correct. 0.01 meters. That is the actual extension. Extension is the increase in length minus the original length, and that is the answer. And so, what is the amount of force? So they are asking us, in this case, this is your E1. We have the first extension here, so E1 is equal to that. So they're asking you for the second force. F2 is not given. And then your E2 is given to be what? It's given to the original length minus L0. In this case, what you have, this is the increase in length, which is 20.05 meters minus 20 all meters. So our E2 is going to be 20.05 minus 20. That will give us 0.05 meters. And so, as we did here also, the stiffness of the material is not given. So we have to use the first information to find the elastic constant of the material. So write that from Hooke's law, F1 is equals to Ke1. We don't have to write K1 or K2 here because the elastic constant of the material for a particular material will not vary, even if you have different forces acting on the material. And so we write that this implies that our K is equals to F1 divided by E1. So if you do that correctly, we substitute now so that our K is equals to F1 is 50 Newton divided by E1. Our E1 is 0.01 meters. If you evaluate that correctly, we have 50 Newton divided by 0.01 and that will give us 5,000 Newton per meter. That is the stiffness of the material. So from F2 is equal to KE2. We substitute now. So this implies that our F2 is equal to K. We have 5,000. Our E2 is what? We have 0.05. Good. So let me put down there. Our F2 is equal to 5,000 Newton per meter times 0.5 meters. Meters, we count out meters, and then you have it at your 5,000 times 0.05 will give you 250 Newton. Therefore, your F2 is equal to this, and that is the correct answer. As simple as A, B, C. Next question. The extension in a spring is 5 grams weight. Sorry, the extension in a spring when the 5 gram weight was hung from it was 0.56 cm. If Hooke's law is obeyed, what is the extension? What is the extension caused by the load of this weight? This is a JAMB question. I love the question. So follow me up, let's solve this one as well. So we proceed without wasting more time. This is question number 4. Question number 4. So apply the 5 C's of calculations. This one is a bit technical. I will lead you through it. So we write there are 2 masses there, and we got to convert the masses to force. So recall that hints from F is equal to mg, mass times gravity. We're going to convert the masses to force with this equation. We call it equation star. So from here we write that from here our data, our m1 is equal to, and before you do this you have to convert your mass to kilogram before you convert it to force. So we write that our 5 gram divided by 1,000 will be the value of the mass in kilogram. That's our first F1. M1. 5 by 1,000. It will give us 0.005 kilogram. So we write out here from there our F1 is equal to our M1 times gravity. And this is 0.005 times 10. Times 10, and that will give us 0.05 Newton. That is the value of the first force. So it's hung an extension, and that force gave an extension E1 to be 0.56 cm. You have to convert that to meters. So write at 0.56 cm divided by 100, that will give us 0.0056 meters. So if Hooke's law is obeyed, meaning if the elastic limit is not exceeded, what is the extension caused by that? So the axis of E2 in this case, what is E2? Caused by a force of what? By extension of what? Our M2 in this case is 20 grams divided by 1,000, and that will give us 20 by 1,000. That will give us 0.02 kilogram. That is the value for so our F2 from the mass is given to be M2 times gravity, and that is 0.02 times 10. If you do that correctly, you are going to have 0.2 Newton. So we are going to find the stiffness of the material. The K is not given. So we write that our F1 is equal to KE1. So this implies that our K is equal to F1 divided by E1. And by substitution, we have that our F1 is a 0.05 divided by E1. Our E1 is a 0.0056. If we do that correctly, we have a 0.05 divided by 0.0056. And we have 8.9286 Newton per meter. This is the stiffness of the material. So from here we have that our F2 is equal to KE2. So we are going to make E2 the subject of the formula. So this implies that E2 is equal to F2 divided by K. And so therefore E2 is equal to our F2 is 0.2 Newton divided by 8.9286 Newton per meter. Newton will also have Newton. And so we have 0.2 divided by 8.9286. So our E2 is given to be 0.02240 meters. As simple as ABC. To this, we have come to the end of this particular video series. Don't forget to subscribe, like, and comment. Follow me. Let's move to the next part of the calculations.